Hello class, welcome to our lesson today dealing with section 3.2, which is radian measurements and their application into some different topics. There's some formulas over the next couple lessons that you just want to have written down and off to the side somewhere so you can reference everything. Also pay attention to when you should leave things with pi in it and when you should make things a decimal answer. Those would be some things to think about for this lesson. First application we're going to look at is what's known as arc length. Arc length is kind of a byproduct of dealing with radian measurement and kind of that relationship between the distance around and the diameter of the radius. Notice that S is the arc length, so that's the distance around the circle. Theta is the angle, but theta must be in radians. Okay, that's the key to the question. And then R is the radius. You've been doing this formula actually for a long time because circumference is 2 pi r. So if you use this formula, the radius times 1 time around the circle is 360 or 2 pi radians. So this formula is just a more general formula if you have part of a circle compared to circumference, which is the whole circle. But remember that theta must be in radians. Okay, so this question set up perfectly. You have the radius and then you have the angle. Remember, if there's no degree symbol, that's implying that's in radians. This should just be plug it in. And in general, you typically are going to have answers that are a decimal here, especially if this first number is a decimal. Your homework will tell you what to round to, same with the assessment. The units here, I didn't focus too much on units, but the units for arc length should be the same as the units for radius, so they both be centimeters. Make sure you try this question and are able to plug in everything together at one time. That'd be something to think about as you're going through the question. Next situation, it gives you a radius of 4 and an arc length of 6, and you want to solve for theta. It's just division. Most likely, if there's two whole numbers, it's just simplify and make an improper fraction or mixed or a regular fraction if it's less than 1. You'll probably not make as many of those decimals. It kind of just depends. But that would be 2 or 3 over 2 radians. If you had to make it degrees, you'd have to multiply it by 180 and divide by pi. Okay, next one, the red flag is that this angle is 135. You can take care of that very quickly by taking 135 times pi over 180. Now this is one of your exact value pieces, but you're just going to plug all this into your calculator anyway. So make sure you're able to plug all those pieces in to find the answer. One thing that I've noticed is that if you use 3.14 instead of the pi button, sometimes you may be off by 100th, and that's going to cause your answer to be wrong. So make sure you're using the pi button whenever you can and where it's applicable in order to find the answer. And this would be 171.77 centimeters for this question. Okay, one application that we're going to look at is dealing with a distance between two cities. This is obviously a little bit different now because of things like Google Earth and Google Maps and other applications like that. But the idea is, since the surface of the Earth is a circular surface, obviously you have terrain to deal with and things like that, but you can kind of get a good estimate of distances this way. This idea works really well with cities that are kind of inline north-south. It would work east-west if you did the same thing, but ones that line up. So if you look at a map, Los Angeles and Sacramento are basically straight due north and south from each other. One has a latitude of 39 degrees north, the other has 34 and 39 degrees north, excuse me. Essentially what you have to do is find the angle between them. So the angle between would just be a simple subtraction, higher minus lower. So 39 minus 34, and that would be 5 degrees. Same issue as the last slide. You have to multiply by pi over 180, and they tell you the radius of the Earth is 6,400. And then multiply all that together, so the distance between the two cities is approximately 558 kilometers. And again, it's kilometers because the radius of the Earth was kilometers. One thing I will mention on a question like this is if one of these is north and the other south, you can't subtract them, you actually have to add them, because think about it, one's above the equator, one's below. So that should make the angle larger because the distance between them would be the two added together. It'd be similar if you added a positive or subtracted a positive and a negative, and that minus a negative becomes plus a positive. So it's that same reasoning for like one's below sea level and one's above sea level. So this logic would be similar if one is degrees north and one is degrees south. But it's just an arc length question as you're dealing with it. Okay, I wanted to review a little bit of exact values again and reference angles. So cosine of 3 pi over 4, remember pi over 4 has a 45-degree reference angle, times 3 would be 135, which is in quadrant 2. Uh, Nice thing about 45 is it's 1 over root 2 for sine and cosine. The only issue is if it's positive or negative. And in quadrant 2, cosine is negative, so the answer is negative root 2 over 2. Tangent of 5 pi over 3. Pi over 3 has a 60-degree reference angle. 5 times 60 is 300, which is in quadrant 4. So the answer is negative because tangent is negative in quadrant 4. And tangent of 60 would be root 3 over 1, which simplifies down to root 3. Combine that together, and you get negative root 3 as your answer. Hopefully you're getting a little bit better with your reference angles, knowing what you need to look at for your triangles. Make sure you're looking at those ideas to be faster and find answers a little bit quicker and be able to explain why something's positive and why something is negative. Cosecant 5 pi over 6. Pi over 6 is a 30-degree reference angle times 5, okay, would be 150, which is in quadrant 2. Find sine and then flip it. So sine of 150 is 1/2. You flip that and it's just 2. And it's positive because sine is positive in quadrants 1 and 2. Remember, the oddball is kind of sine of 3 pi over 2, which is a 90-degree reference angle. As soon as you have a 90 or 180-degree reference angle, that's a sign that it's quadrantial. And sine of 90 should be 1, but it's down below, so it's actually 270. Okay, so 270 sine is negative 1. You could also use the y value on the circle idea, and that's negative 1 over 1, which is negative 1. Okay, that's the applications for today. Remember, arc length, S equals r theta, and then you plug in 2 of the 3 and find the missing piece, but theta always has to be in radians. Make sure you check your calculator, everything's set up well. Have a good day, everybody.